Hi, I'm Luke Kane. Welcome to Algebra 2. Today we're going to solve a 3x3 system of linear equations by substitution. You may recall that the last time we solved a 2x2 system of linear equations by substitution, and we observed that it was like musical chairs. In musical chairs, if you recall, the way the game is played is we have m+1 players and m chairs. When the music stops, one person is left standing. You remove a chair, repeat the process until you're down to one chair, and then finally whoever's left in that last chair is the winner. Well, it was the same process here. We substituted the equivalent of a variable into one equation, had one equation and one unknown, solved for that equation, plugged the value for that equation into the other equation, and that gave us, again, using the techniques of Algebra 1, the value for that second variable. We checked those variables to make sure that they satisfied both equations, and we're done. Specifically, we had this set of equations. We took the equivalent of the x variable in the second equation, found out that x was equivalent to minus 2y plus 16, substituted that back into the first equation where we got an equation with one unknown. We simplified, solved for y, plugged it back into our system, then we solved for x, and we were done. Okay, now we're going to try the same idea, only on a larger system, a 3x3 system of equations. And it's the same strategy. Basically, we're going to remove variables just like you remove chairs in musical chairs. So to solve this 3x3 system of equations, I'm going to follow the clue that was given to us by the video. Basically, in the video, musical chairs, the game started where we jumped in at 3 chairs and it moved down to 1 chair. Well, we've got 3 variables and we're going to remove it. We're going to move it down to 1. We're going to reduce this to 1 variable and ultimately in 1 unknown. So we're going to take this z and we're going to put its equivalent in place of the first equation, and we're going to substitute it in the second equation. So let's copy the first equation. It's 6x plus y minus z equals minus 2. Alright, we're going to solve for z, which means we're going to move the 6x over to the other side by subtracting 6x from both sides, subtract y from both sides. And what are we left with? That cancels because it's 0. This becomes minus z equals minus 6x minus y minus 2. Multiply this whole thing by minus 1. We do it on the left, we got to do it to the right. Minus 1 times z. Minus times a minus is plus. So that becomes z. Minus 1 times this trinomial. Well, that's going to change the sign of everything. Going to make everything positive. So it's going to be 6x plus y plus 2. Alright, so we found the equivalent of z. Now let's substitute it into equation number 2. Number 2 is what? X plus 6y plus 3z equals 23. Alright, substitute that into the second equation. And what do I get? Copy the first term, copy the second term, substitute in for the third term. 6x plus y plus 2 and copy the right-hand side, 23. Copy the first term, copy the second term, distribute. Third term, 3 times 6x is 18x. 3 times y is plus 3y. 3 times 2 is 6. Copy the right-hand side. Now let's combine like terms. X plus 18x is 19x. 6y plus 3y, that's 9y. Plus what's left over is 6. That whole thing equals 23. I want this in standard form, so I'm going to subtract 6. Oops. Subtract. I'm going to subtract it once from the left-hand side and once from the right-hand side. So that leaves me with 19x plus 9y. Goes away, bye-bye, and that equals 17. Okay, let's do it again for the third equation. What's the third equation? Third equation is minus x plus y plus 2z equals 5. Yeah, we're going to do the same thing. Substitute in for z. So copy the first term, copy the second term. Substitute in for the third term, 6x plus y plus 2. And that whole thing sums up to 5. Okay, copy the first term, copy the second term, distribute the third term, 2. Oops, distribute the third term. 2 times 6x, that's 12x. 2 times y, that's plus 2y. 2 times 2 plus 4. Whole thing is going to equal 5. Combine like terms. Minus x plus 12x, that's going to be 11x. Y plus 2y, that's 3y. And plus 4 is left over. And again, I want this to be in standard form, so I'm going to move the 4 over to the right-hand side by subtracting it from both sides. And I get 11x plus 3y. That goes away, equals 1. So now I have a 2 by 2 system equation. Let's call it equation A, equation B. All right, what I'm going to do is what I've done before. I'm going to solve this equation, equation B, in terms of y, and then substitute the equivalent of y into equation A, and that's going to give me x. Excellent. So let's do that. All right, that means I'm going to subtract 11x from both sides, and now I have, that goes away, and I end up with 3y equals minus 11x plus 1. Divide both sides by 3. Oh, I'm going to end up with nasty fractions. 3 divided by 3 is 1. 1 times y is y, equals minus 11/3 x plus 1/3. That's plus sign unless we get mistaken. And as we've done before, that y is going to be substituted for that y. So we go to equation A, copy the first term, substitute in for the second term, minus 11/3 x plus 1/3. That equals 17. Copy the first term, distribute the second term. Well, that's not going to be too difficult. 9 times minus 11/3 x plus 9 times 1/3 equals 17. So I get 19x, and I'm going to do some arithmetic. 3 goes into 3 once, that goes 3 times. And, oops, this is going to be not plus. This is going to end up being minus. It's going to be minus 33x. And that goes once, that's 3 times, plus 3 equals 17. Okay, 19x minus 33x is minus 14x plus 3 equals 17. I'm going to subtract 3 from both sides. And I get minus 14x. That's gone. Equals 14. divide by minus 14. I get x equals minus 1. Oh, good. Now I can start back substituting. So let me substitute that into that. So I get y equals minus 11 thirds times minus 1 plus 1/3. That's going to equal minus, actually plus 11 thirds, right? Minus times minus is plus, plus 1/3. 11 plus 1 is 12 thirds. 12 divided by 3 is 4. So I have y equals 4. All right. Let's go back and where's our z? Z is in here somewhere. Yes, z equals 6x plus y plus 2. Okay. Z equals 6x plus y plus 2. So now we're going to substitute 6 times minus 1 plus y, which is 4 plus 2, which equals minus 6 plus 4 plus 2, which equals minus 6 plus 6, which equals 0. So I get z equals 0. And my solution is minus 1, 4, and 0. Should we check that? Okay, let's check our solution. All right, let's check equation 1. So equation 1 is 6 times x minus 1 plus 4 minus 0. Does that equal minus 2? Check on equation number 1. Equation number 2. So it looks good for equation 2. Last but not least, equation number 3. Yes, of course. 5 equals 5. So what do we learn? Well, we learned how to solve a 3x3 system of linear equations by substitution. And essentially the process is like musical chairs. We substitute equivalent values for a variable to remove variables, just like chairs are removed in musical chairs. In this particular case, we had 3 equations and 3 unknowns, and we took the first equation in our system and solved it for z, so that we found that z is equivalent to 6x plus y plus 2. We then substituted the equivalent for z into the other 2 equations, which effectively reduced it to a 2x2 system of equations. We repeated the process, and we ended up with a 1x1 system of equations, and using the techniques of Algebra 1, we discovered that x equals minus 1. We then went back and substituted the x equals minus 1 into the y equivalent, which we had determined from the second system of equations. When we substituted x equals minus 1 into the y equivalent, we found that y equals 4. Then we took the value x equals minus 1 and y equals 4, and we back substituted that into our first equivalent, and we discovered that z equals 0. Next time, we're going to solve a 2 equations by elimination. We're going to find out that it is a more direct version of musical chairs. I'm Luke Kane. Thanks for watching. Bye now.